According to the National Electrical Code, or NEC, there is no specific minimum distance mandated between a main feed panel and a sub-panel. However, for practical considerations related to safety and ease of maintenance, it is recommended to maintain certain minimum clearances. Firstly, a vertical clearance of 12 inches, which is approximately 305 mm, is advised. Secondly, a horizontal clearance of 6 inches equating to about 152 mm is also recommended. These clearances are not arbitrary. They serve multiple important purposes. Adequate spacing around electrical panels ensures sufficient room for personnel to access the panel safely. This is particularly crucial during maintenance procedures, troubleshooting scenarios, or when performing upgrades to the electrical system. Sufficient clearance allows technicians to maneuver tools, equipment, and testing devices without undue risk of accidental contact with energized components. Ventilation is another critical factor influenced by panel spacing. Electrical equipment generates heat during operation. Inadequate ventilation can lead to a buildup of heat within the panel enclosure, potentially causing premature failure of components, reduced efficiency, and in extreme cases, fire hazards. The recommended clearances facilitate airflow around the panels, dissipating heat and maintaining a safe operating temperature. Reducing the risk of accidental contact with live electrical components is paramount. The clearances act as a buffer zone, minimizing the likelihood of unintentional contact by personnel working in the vicinity of the panels. This is especially important in environments where untrained individuals may be present. While the NEC does not specify a minimum distance, adherence to the recommended clearances enhances safety and reduces the potential for electrical accidents. Accessibility is a key factor in electrical system design. Panels should be readily accessible for inspection, maintenance, and repairs. Obstructions or inadequate spacing can hinder access, making it difficult to perform necessary tasks efficiently and safely. The clearances ensure that technicians can reach all parts of the panel without undue difficulty. Furthermore, it is important to acknowledge that the recommended clearances represent a baseline. In certain situations, it may be necessary to increase the distance between panels to accommodate specific requirements. For instance, if there are obstructions in the vicinity of the panels, such as pipes, ducts, or structural elements, the spacing may need to be increased to ensure adequate access and ventilation. Similarly, if the panels are located in a high-traffic area, additional clearance may be warranted to prevent accidental contact or damage. The panels themselves should be securely mounted to a stable surface. Proper mounting prevents the panels from shifting or becoming dislodged, which could compromise the integrity of the electrical connections and create a safety hazard. The mounting method should be appropriate for the type of panel and the supporting structure. It is also essential to ensure that the conductors connecting the main feed panel and the sub-panel are properly sized and protected. The conductor size must be adequate to carry the anticipated load current without overheating. The conductors should be insulated to prevent short circuits and ground faults. Additionally, the conductors should be protected from physical damage by routing them through conduit or other protective enclosures. Clear and accurate labeling is crucial for easy identification of the panels and their associated circuits. Each panel should be labeled with its designation, voltage, and amperage rating. The circuits within the panel should be labeled to indicate the loads they serve. Proper labeling facilitates troubleshooting, maintenance, and future modifications to the electrical system. Consider the working space requirements outlined in the NEC. The code specifies minimum working clearances in front of electrical equipment, including panels. These clearances are intended to provide ample room for personnel to work safely and effectively. The working space must be clear of obstructions and must extend a minimum distance from the front of the equipment. The depth of the working space varies depending on the voltage of the equipment and the presence of exposed live parts. Also, consider the ambient temperature around the panels. Excessive heat can degrade the insulation of conductors and other components, reducing their lifespan and increasing the risk of failure. If the panels are located in a hot environment, it may be necessary to provide additional ventilation or cooling to maintain a safe operating temperature. The NEC provides guidelines for dating conductors based on ambient temperature. The dating factors are used to reduce the allowable ampacity of conductors to account for the effects of heat. Furthermore, consider the potential for corrosion. If the panels are located in a damp or corrosive environment, it is important to protect them from moisture and chemicals. This can be accomplished by using corrosion-resistant enclosures, applying protective coatings, and providing adequate ventilation. Corrosion can damage electrical components and compromise the integrity of the electrical connections. Lastly, it is important to consult with a qualified electrician or electrical engineer to ensure that the installation meets all applicable codes and standards. A professional can assess the specific requirements of the application and provide guidance on the proper spacing, mounting, wiring, and labeling of the panels. Adhering to these best practices will enhance the safety, reliability, and maintainability of the electrical system. Remember that electrical work can be dangerous and should only be performed by qualified personnel. Always de-energize circuits before working on them and follow all applicable safety procedures. The information provided here is intended for general guidance only and should not be considered a substitute for professional advice. The NEC is a comprehensive document that provides detailed requirements for electrical installations. It is essential to consult the NEC and any applicable local codes to ensure compliance. The NEC is updated regularly to reflect changes in technology and best practices. Staying up to date with the latest edition of the NEC is crucial for ensuring the safety and reliability of electrical systems. Electrical installations are subject to inspection by local authorities. It is important to obtain the necessary permits and inspections to ensure that the installation meets all applicable requirements. Failure to comply with codes and standards can result in fines, penalties, and potential safety hazards. Regular maintenance is essential for ensuring the continued safe and reliable operation of electrical panels. Maintenance procedures should include visual inspections, cleaning, tightening of connections, and testing of components. A qualified electrician should perform maintenance on a regular schedule, typically at least once a year. When performing maintenance, it is important to follow all applicable safety procedures. Always de-energize circuits before working on them and use appropriate personal protective equipment, such as gloves and safety glasses. Be aware of the potential hazards associated with electrical work and take steps to mitigate those hazards. Electrical safety is everyone's responsibility. By following safe work practices and adhering to codes and standards, we can help prevent electrical accidents and protect lives and property. In addition to the clearances around the panels, it is also important to consider the clearances around other electrical equipment, such as transformers, switchgear, and generators. The NEC specifies minimum working clearances for all types of electrical equipment. These clearances are intended to provide ample room for personnel to work safely and effectively. The working space must be clear of obstructions and must extend a minimum distance from the front of the equipment. The depth of the working space varies depending on the voltage of the equipment and the presence of exposed live parts. Consider the location of the panels in relation to other building systems such as plumbing, HVAC, and fire protection. The panels should be located in a dry, well-ventilated area that is protected from water damage. They should not be located near flammable materials or in areas where they could be exposed to physical damage. The panel should also be located in an area that is easily accessible for maintenance and repairs. The design of the electrical system should take into account the future needs of the building. The panels should be sized to accommodate the anticipated load growth. Spare capacity should be provided for future circuits. The electrical system should also be designed to be easily expandable and adaptable to changing needs. The installation of electrical panels should be performed by a qualified electrician who is familiar with the NEC and any applicable local codes. The electrician should have the necessary training, experience, and tools to perform the work safely and effectively. The electrician should also be licensed and insured. Before starting any electrical work, it is important to obtain the necessary permits and inspections. The local authorities will inspect the work to ensure that it meets all applicable codes and standards. Failure to obtain the necessary permits and inspections can result in fines, penalties, and potential safety hazards. Regular inspections of electrical panels are essential for ensuring their continued safe and reliable operation. Inspections should be performed by a qualified electrician on a regular schedule, typically at least once a year. The electrician will inspect the panels for any signs of damage, overheating, or corrosion. The electrician will also test the components to ensure that they are functioning properly. Any problems that are identified during the inspection should be corrected promptly. Consider the use of arc flash protection. Arc flash is a dangerous electrical hazard that can occur when there is a short circuit in the air. Arc flash can cause severe burns, blindness, and even death. Arc flash protection can help to reduce the risk of arc flash injuries. Arc flash protection measures include the use of personal protective equipment, such as arc-rated clothing and face shields, and the installation of arc flash mitigation devices, such as arc flash relays and current-limiting fuses. It is important to conduct an arc flash hazard analysis to determine the potential arc flash hazards in the electrical system. The arc flash hazard analysis will identify the areas where arc flash protection is required. Grounding is a critical safety measure that helps to protect against electrical shock. Grounding provides a path for fault current to flow back to the source, tripping a circuit breaker or fuse and energizing the circuit. All electrical panels and equipment should be properly grounded. The grounding system should be installed in accordance with the NEC and any applicable local codes. Surge protection is another important safety measure that helps to protect against voltage surges. Voltage surges can be caused by lightning strikes, power outages, and other electrical disturbances. Voltage surges can damage sensitive electronic equipment, such as computers, televisions, and appliances. Surge protection devices, or SPDs, can help to protect against voltage surges by diverting the excess voltage to ground. All electrical panels and equipment should be protected by SPD. Remember that electrical safety is a shared responsibility. By following safe work practices, adhering to codes and standards, and taking the necessary precautions, we can help to prevent electrical accidents and protect lives and property. Lastly, do not forget to properly label all circuit breakers and electrical panels. This ensures that anyone working on the system can quickly identify and isolate the correct circuit. Accurate labeling is essential for safety and efficiency during maintenance, troubleshooting, and repairs. Use a permanent marker or label maker to create clear, easy-to-read labels. Consider creating a panel directory that lists the loads served by each circuit breaker. Keep the directory up to date as circuits are added or modified. Clear and accurate labeling is a simple yet effective way to enhance the safety and usability of your electrical system.